Hello again. I am here to show you another example of a compound transformation. That means we're taking a pre-image and making two images out of it, doing two different transformations on it. So I can see in my instructions, the first thing I'm going to do is I'm going to take this square, LMNP, and I'm going to translate it x plus 6, y minus 8. I'm going to give you a second in the Nearpod. That x plus 6, what direction does that mean my rectangle is going to move? If you said to the right, you're correct. And that y minus 8, what direction is that going to make my rectangle move? If you said down, you're 100% correct. So I'm going to go ahead and do that. And then after that, I'm going to reflect that new image over the y-axis. So all of my points, I'm going to start with L, and I'm going to go right 6, down 8. So I'm going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Here's L prime. It's at 1, 2, 3, 4, negative 1. 4, negative 1. And notice if I added 6 to negative 2, I would get 4. If I subtracted 8 from 7, I would get negative 1. So I could either just calculate all the points by adding 6, subtracting 8, or I can just do it on the graph. This one I'll just do it on the graph. So M is right 6, 1, 2, 3, 4, 5, 6, down 8. 1, 2, 3, 4, 5, 6, 7, 8. That's my M prime. And its coordinates are, let's see, over 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 8, negative 5. 8, negative 5. And if I add 6 to 2, like my rule says, I get 8. If I take 3, take away 8, that's negative 5. N prime, I'm going to go right 6, down 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. There's N prime. And finally, P prime, right 6, 1, 2, 3, 4, 5, 6, down 8, 1, 2, 3, 4, 5, 6, 7, 8. And my points for N is at 6. 0 plus 6 is 6, and should be 5 minus 8. That should be negative 3. And it does look like it's at, or negative 7. Negative 7, my bad. Negative 7. Take my 1, take away 8 is negative 7. And that goes negative 7 down there. And then finally, P prime is at, if I take negative 4 and add 6, that's 2. And 5 minus 8, that's negative 3. 2, negative 3. That works. I'm going to take a second. I'm going to pause the camera, and I am going to connect the dots of my rectangle. All right, so I have connected my dots. So I just took my rectangle and took the whole thing and went right 6 and down 8. And because every point moved in the same direction, I have a congruent rectangle here. Rectangle LMNP is congruent to L prime, N prime, N prime, P prime, because every point moved the same amount. So all the side lengths are the same, the angles are the same, nothing changed. Now I have to take this one and reflect it over the y-axis. So I'm going to give you a minute, and in the Nearpod, I want you to tell me what direction is the rectangle going to move now. All right, let's see if you're correct. So When I reflect across the y-axis, so I'm reflecting across it up and down, I'm going from over here to over here. And I can just count. So my first point L is 1, 2, 3, 4 to the right of the y-axis. So I have to go 1, 2, 3, 4 to the left. That's L double prime. P is 2 to the right on the y-axis, so I have to go 1, 2 to the left. That's P double prime. N was 1, 2, 3, 4, 5, 6 to the right. I'm going to go 1, 2, 3, 4, 5, 6 to the left. I count that again. 1, 2, 3, 4, 5, 6. There we go. That's N prime. And finally, M prime is all the way on the other side. I'm just going to go all the way to the edge of the graph on this side too. Double prime. M double prime. So when I look at L, I went from 4, -1 to -4, 1. M was at 8, -5. Now I'm at -8, 5. Take a look. We went from 4, -1 to -4, -1. My bad. Here we went from 8, -5 to -8, -5. I don't know why I left the negatives off. And I still have an N double prime is at -1, 2, 3, 4, 5, 6. And it's down 7, so -7. So take a look. See what changes from here to here and make a prediction for where P double prime will be. If you noticed that the X values become the opposite and the Y values stay the same, you're absolutely correct. So -2, -3. So we did 2 transformations. Here's my pre-image. This is just let me get one more color here. This one here is just my original points, X, Y. And then I transformed them into an image that had the rule to the right 6, down 8. And then from there, I reflected over the y-axis. That meant my y's stayed the same and my x's were the opposite. So opposite of x, y. And there's another example of doing a compound transformation where this time, instead of doing 2 reflections, we did a translation and then a reflection. We also could have done a reflection and then a translation. There's a lot of different possibilities. Pretty soon we're going to learn how to do rotations and dilations, so you'll have 4 different ways that you can transform shapes on the coordinate plane. All right, thanks guys.